Hello students, in today's lecture we are going to learn about units and measurements, and this is theory part. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So in today's lecture, we will cover combination of errors. Like first, we will cover error of a sum or a difference. After that, we will learn error of a product or a quotient. Then we will learn error in case of a measured quantity raised to a power. So, errors of measurement. Our main aim to understanding error propagation in mathematical operations and measurements. Combination of errors. Combination of errors in various mathematical operations are as follows. First is error of a sum or a difference. Suppose we have a two quantities and we added or subtracted. The absolute error in the final result is the sum of the absolute error in the individual quantities. Suppose the quantity is Z. If Z is equal to A plus B, A plus B. So if we added two quantities A and B, or we can say Z equal to A minus B. If we subtracted two quantities, so here again the same quantities is same A and B. Now error of a sum or a difference, here we find the error. If we talk about the sum, so Z is equal to A plus B, and if we talk about the difference, it will be A minus B. We have by addition Z plus minus delta Z is equal to A plus minus delta A plus B plus minus delta B. Here we have a quantities Z is equal to A plus B and Z is equal to A minus B. Now if we talk about the Z is equal to A plus B, in that case the error in Z is Z plus delta Z. If we talk about the A plus B, and error in A is A plus delta A, and error in B is B plus delta B. If we talk about the A minus B, in that case Z will be Z minus delta Z, A minus delta A and B minus delta B. So this is the representation of the absolute error. Delta Z is absolute error here. Similarly, delta A is absolute error and delta B is absolute error. The maximum possible error in Z is what? So the maximum possible error in Z is delta Z is equal to delta A plus delta B. So this is the maximum possible error. Now if we talk about for the difference, where Z is equal to A minus B. So in that case we have Z plus minus delta Z is equal to A plus minus delta A minus B plus minus delta B. So it will be A minus B plus minus delta A plus minus delta B. Here delta Z, delta A and delta B is the absolute error. Delta Z, delta A and delta B represents absolute error. So plus minus delta Z is equal to plus minus delta A plus minus delta B. So this is the maximum possible error if we have a quantity Z is equal to A minus B. However, the maximum value of error delta Z is given as delta Z is equal to delta A plus delta B. So this is the maximum value of the error. Hence, the rule, when two quantities are added or subtracted, listen carefully, when two quantities are added and or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. So here the absolute error is equal to the sum of the absolute error of the individual quantities, delta A plus delta B. Clear? So here question is, the temperature of two bodies, solve this question. The temperature of two bodies measured by a thermometer are T1 equal to 20 degrees Celsius plus minus 0.5 degrees Celsius and T2 is equal to 50 degrees Celsius plus minus 0.5 degrees Celsius. Calculate the temperature difference and the error therein. So here you have to find out the temperature difference and the error. So what is the answer? Solution. So here T prime is equal to T2 minus T1. So this is the temperature difference. Here temperature difference is T prime. Now T2 is what? T2 is 50 degrees Celsius plus minus 0.5 degrees Celsius and T1 is 20 degrees Celsius plus minus 0.5 degrees Celsius. So we know the value of T1 and T2. So just substitute the value of T1 and T2. You will be get this expression. 50 degrees Celsius plus minus 0.5 degrees Celsius minus 20 degrees Celsius plus minus 0.5 degrees Celsius. So it will be what? So solving this, 50 degrees Celsius minus 20 degrees Celsius. So it will be 30 degrees Celsius and plus minus 0.5 degrees Celsius and this one 0.5 degrees Celsius is equal to 0 plus minus 1 degree Celsius. So the temperature difference is this one. Clear? Second is error of a product or a quotient. When two quantities are multiplied or divided. Suppose we have two quantities and we want to multiply and divide division. In that case, the relative error in the result is the sum of the relative errors in the multipliers. So suppose we have the quantity Z is equal to AB. Z is a quantity and the measured values of A and B are this one, A plus minus delta A and B plus minus delta B. Then Z plus minus delta Z is equal to A plus minus delta A, B plus minus delta B. So it will be become AB plus minus B delta A plus minus A delta B and plus minus delta AB. So when we solving this, so multiply it A into B. So AB, then A into plus minus delta B. So it will be plus minus B into delta A. After that, multiply delta A with A, B. So it will be plus minus A into delta B and plus minus A delta and delta B. dividing LHS by Z and RHS by AB, we have 1 plus minus delta Z divided by Z is equal to 1 plus minus delta A divided by A plus minus delta B divided by B plus minus delta A divided by A into delta B divided by B. Since delta A and delta B are small, so we ignore their product. So this is the all about the product. Hence the maximum relative error delta Z by Z is equal to delta A by A plus delta B by B. You can easily verify that this is true for division also. Let's see. Hence the rule, when two quantities are multiplied or divided, the relative error in the result is the sum of the relative errors in the multipliers. So suppose we have a two quantity A and B, and it will be like this. Z is equal to A divided by B. So the relative error is this one, delta A divided by A plus delta B divided by B for the both cases, division and multiplication. Now question, the resistance R is equal to Vi, where V is equal to 100 plus minus 5 volt and I equal to 10 plus minus 0.2 ampere. Find the percentage error in R. So here you have to find out the percentage error in R. What is the solution? Please solve this question. The percentage error in V is 5% and in I is 2%. The total error in R would be therefore be 5% plus 2% is equal to 7%. Clear? So here question is, two resistors of resistances R1 is equal to 100 plus minus 3 ohm and R2 is equal to 200 plus minus 4 ohm. Ohm is the unit of resistance. Connected. First combination is series combination and second combination is parallel combination. Find the equivalent resistance of the A series combination, B parallel combination, and the given is, use for A the relation R is equal to R1 plus R2 and for B 1 upon R prime is equal to 1 upon R1 plus 1 upon R2 and delta R prime divided by R prime square is equal to delta R1 divided by R1 square plus delta R2 divided by R2 square. So find the answer of A and B. So first is the equivalent resistance of the series combination. If we talk about the series combination, the resistance will be added end to end. So R1 plus R2. If we talk about the series combination, here R1 is this one 100 plus minus 3 and R2 is 200 plus minus 4 ohm. So 100 plus minus 3 ohm plus 200 plus minus 4 ohm. This is for the series combination. So when we added 100 plus 200, it will be 300. And for this plus minus 3 and plus minus 4, it will be plus minus 7 ohm. So this is the equivalent resistance of the series combination. Second is the equivalent resistance of parallel combination. So if we talk about the parallel combination, the formula is R prime is equal to R1 R2 divided by R1 plus R2. This one. So we know the value of R1, we know the value of R2. So just substitute the value of R1 and R2, you will be get the R prime. So R1 is this one 100 and R2 is 200. So solving this, you will be get 66.7 ohm. 66.7 ohm. Then 1 upon R prime is equal to 1 upon R1 plus 1 upon R2. So we get this one delta r prime divided by r prime square is equal to delta r1 divided by r1 square plus delta r2 divided by r2 square. So delta r prime is what? This one. R prime square, when we multiplied r prime square with this term, you will be get r prime square into delta r1 divided by r1 square plus r prime square into delta r2 divided by r2 square. So we know the value of all given terms. R prime, delta r1, r1, just substitute the value. So after substituting the value, you will be get 66.7 divided by 100 whole square into 3 plus 66.7 divided by 200 whole square into 4. So you will be get 1.8. So delta r prime is equal to 1.8. So r prime is equal to 66.7 plus minus 1.8 ohm. Here delta r is expressed as 1.8 instead of 2 to keep in conformity with the rules of significant figures. About the significant figures, we will learn in upcoming section. So 8.8 and 1.8 is the delta r prime. Third is error in case of a measured quantity raised to a power. The relative error in a physical quantity raised to the power k is the k times the relative error in the individual quantity. So if we have z is equal to a raised to the power p, b raised to the power q and divided by c raised to the power r, then the relative error is this one, p into delta a divided by a plus q delta b divided by b plus r delta c divided by c. Hence the rule, the relative error in a physical quantity raised to the power k is the k times the relative error in the individual quantity. So if we have a quantity like this, so the calculation is this one. Clear? If you have any doubt, please ask. So question is, find the relative error in z if z is equal to a raised to the power 4, b raised to the power 1 by 3 divided by c and d raised to the power 3 by 2. So what is the answer? Here you have to find out the relative error. Please solve. The relative error in z is delta z by z. So here power is 4. So power comes with multiplication with relative error of a. So it will be delta 4 into delta a divided by a plus next term is b. So power is 1 by 3. So power comes with multiplication. So 1 by 3 into the b become in terms of relative error. So it will be delta b divided by b plus c. So it will be here in the power of c is 1. So it will be delta c divided by c. Now next term is d. The power is 3 by 2. So 3 by 2 into and the term is d. So delta d divided by d. So this is the representation of the relative error if the quantities are given like this. This is clear? Question. The radius of sphere is 5.3 plus minus 0.1 centimeter. The percentage error in its volume is what? So here you have to find out the percentage error. Please solve. We know the volume of sphere is V is equal to 4 by 3 pi r cube. This is the volume of sphere. Formula for percentage error propagation for measurement x raised to the power n, the percentage error multiplied by n is this one. If the given term v is equal to k raised to the power n, so the percentage error will be delta v divided by v into 100%. The only term, if we talk about the only term delta v divided by v, so this is the relative error, and if we multiplied it with 100, so it will be become percentage error. So the term v is equal to 4 by 3 pi r cube. So there 4 by 3 and pi are the constant term, so neglect this. So remaining term is r raised to the power 3. So apply it to the sphere where n is equal to 3. When we compare v with this formula, v is equal to k raised to the power k into k r raised to the power n. So the percentage error is equal to 3 into 3, power comes outside, so 3, and the relative error of delta r divided by r. So delta r is what? 0.1 and r is 5.3. Here this is the only relative error, but we want to calculate the percentage error, so multiplied it with 100%. So you will be get the percentage error in v. So v is equal to 3 into this one. So the solution of this quantity is 1.89% with this. So overall is 5.67%. 5.67% is the correct answer. The resistance R is equal to V divided by I, where V is equal to 100 plus minus 5 volts and I is equal to 10 plus minus 0.2 amperes. What is the total percentage error in R? So here you have to find out the total percentage error in R. Please solve this question. So solution. The formula is R is equal to V by I. So if we want to calculate the percentage error, so first of all we calculate the relative error. So relative error is delta R by R, and if we multiply it with 100, so it will become a percentage error. So this is the percentage error. Now if we talk about V by I, so it will be V delta V divided by V into 100. So this is the only relative error. Now after multiplication with 100, it will become percentage, and it I, so it will delta I divided by I into 100. So the error is delta V is 5 divided by V is 100 into 100 plus delta I is 0.2 and I is 10 into 100. We already solved this question. So 5 plus 2% is equal to what? 7%. Now it is clear? This is very simple. According to Joule's law of heating, heat produced H is equal to I square RT, where I is current, R is resistance and T is time. If the errors in the measurement of I, R and T are 3%, 4% and 6% respectively, then error in measurement of H is what? So here you have to find out the error in measurement of H. Solution. The formula is H is equal to I square RT. So here we have to find out the percentage error. So H, delta H divided by H, this is the relative error, and multiplying with 100, it will become percentage. Now here the first term is I square, so power is 2, so power comes outside and the remaining term is I. So 2 into delta I by I plus R, so delta R by R plus delta T by T. We know the value of relative error of delta I by I, so this is 3. So 2 into 3, and delta R by R is 4 and delta T by T is 6. So it will be 2 into 3 plus 4 plus 6. So 6 plus 4, 10 and 6, 16%. 16% is our answer. Clear? Thank you for your attention.